Ladies and gentlemen, we had a request to do the Newman question from Fall 22 Test 1, Part 4. You will be given a picture and told how to look at it. You have no degrees of freedom here. You are a slave to these instructions. You got to put your eyeball in looking at carbon 6 so that carbon 5 is invisible. The only way to put your eyeball is looking this way right there. And this is my lame attempt at an eyeball right here. And I don't know, it's got something going on there and an eyelash. That's pretty lame. That's okay. You have to be over there. I will be wandering over there. Okay? I'm not that tall. I'll be wandering over there now. Okay, not right now. I've got strategies for you on this question because it's intimidating as all get up. For a person like me, you want me to visualize. Right away, I've got anxiety. Okay? So draw the ball, which represents the front carbon. So just a circle. You're going to need it every time. That's carbon 6. Every time. I want to see the 3 bonds sticking off of 6 that aren't the 1 to 5, because 5's right behind the ball, right? Which bond should you choose to draw first on each of the carbon 6 or 5? It's the bond that's not a wedge or a dash, because that bond will either be straight up or straight down. And that's easy to draw. If I tell you to draw something straight up, you're going to go straight up. If I tell you to draw something straight down, you're going to go straight down. You don't have to worry about left and right. That's the beauty of the bond. It's not a wedge or a dash. So off of carbon 6, the bond is 7. Is it straight down or straight up? Straight down. I'm drawing it first. I'm just a hint here. You're going to do green first. Well, I guess I did blue first, but you know what I mean. That's carbon 7. That's 8, 9, 10, and there's a methyl on 7. And then I'm going to get over to the screen and figure out which hand that I need to use to grab the iodine. I will be going over there. You might see me on the, I don't know, you're not going to see me on the video. No. I don't know. We'll give it a try. Yeah. Could look goofy. All right, I am where I need to be, right? I have to stand here. I can't be over there. It means I can't read if I'm over there. I can read. And which hand am I using, quite literally, to grab the eye? Is it my right hand or my left? It's my right hand. And is it a little below the level of my eye or a little above? A little above to my right. Draw that. And we're back. A little above and to my right. And they have to be evenly spaced on the ball, okay? Evenly spaced. So don't be going like this, no, too sharp an angle. Don't be going like this, no, it's straight up. Don't do that. Up to the right, and the last bond you have to draw, I'm guessing it's the other group, but I'm going to verify that by going back where I should be. The other group is called a dibromopropyl, 3,3 dibromopropyl. We're back over there. All right, I'm here. Which hand to grab the 3,3 dibromopropyl? Left. And a little above my eye. Not below, above. So, yeah. All right, we're back. Dibromopropyl. There's 1, 2, 3, and 2 bromos on the end there. That's one way to do it. Front carbon's done. Nice job. Back carbon, start the same way. The group that's not a wedge or a dash off of carbon number 5. Which group is it? Is it the hydrogen or the sec isopentyl or the 2,3,3 dimethyl butyl? That's the one, right? This one, straight up or down? Hey, that means it's right behind this. Are you terribly surprised? No, look, if you're looking here, this is right in front of this. This is right in front of this. This is right in front of that. This is like eclipsing, isn't it? Yeah. Okay, so you told me straight down for 4 and then 4, 3, 2, 1. We'll go with different colors back there. When you're drawing off the back carbon, you don't see the whole bond because the ball is hidden, right? You see everything past the front carbon. So 4, 3, 2, 1 with methyls here, and no, it wasn't there. Oops. 4, 3, 2, 1 with methyls here and here and here. I got it, right? You want some numbers? 4, 3, 2, 1, 7, 8, 9, 10. You don't need to show me these numbers, people. It's just for you. That 3 looks pretty bad, I know. What about, I'm not going to go back over to the screen. The iodine. This iodine is in front of which group on the carbon 5? Hydrogen. The dibromopropyls in front of this group, right? I lost my mouse. There it is. This group here, they're in front of each other, right? That's this group. CH2 goes to the bromo. CH with a methyl. And looks like we're going black here. CH with a methyl goes to C with a V. There it is. And there you have your molecule. 3 points. All the hard work was this one. Everything after this is, if you did a good job here, 3 fast points and then 3 more fast points. This was the slow point. The question now is, you want to get the bulky groups, the bulkiest groups on the front and back carbon right in front of each other. That would be the worst case scenario, right? For stability. You got a big group in front of a big group, they're like almost touching, right? Because they're so big. Bulky is the better word, right? So what's the bulkiest group on the front carbon? And please don't forget the periodic table tells you that iodine has a mass that's 10 times higher than carbon. It's more than 10. Guys, you got a big fat atom directly attached to the carbon number 6, correct? That's the bulkiest atom. Iodine is massive. I'm going to highlight it. I'm just going to say, I'm just highlighting the bulkiest. You don't have to do any of this. This is just the teacher trying to make this question clear for you. What about the back carbon with these 3 groups? Hydrogen, the sec group, and this group that's not quite sec. I think I answered my own question. Which of those 3 groups has branches? This one and this one. Which one has the branch closer to carbon number 6? This one. That makes it bulkier. So right now, this is not the least stable eclipse, is it? Whoa, that wasn't nice. I just got a straight dot I didn't like. Okay, got straight dots everywhere. I need those groups to be right on top of each other, right? What strategy do you want to use? Do you want to rotate only the back carbon or rotate only the front? I think the back one's okay with me. I'll do that. So I'm just going to copy the front carbon 2 more times because I'm not rotating that one today. I just made that decision now. Well, you made it for me. So front carbon, copy it. And it's got this. And do it again. You did all that hard work. Now you're getting points for just copying your hard work. We love that. Okay, back carbon needs to rotate how many degrees to get this highlighted group behind the iodine? Give me a number and a degree sign. The number has to be less than 360. 120, positive, right? So that's rotating 120. The H is rotating 120, and the baby blue is rotating 120. Okay, we'll make them all baby blue this time. H rotated 120 to get to here. The bulky group is now behind the iodine, and the other group was the I don't even know what it's called. It's 2,3,3 dimethylbutyl. 2,3,3 dimethylbutyl. And I would have preferred if this bond was a little closer. Eraser, small. I would have preferred if that ended up being closer. There. Clearly eclipsed, right? And I put it in the wrong box. Oh, I hate when I do that. I was supposed to put this in the second box. Nah, I want to move it. It's not easy. Seems like it should be, right? Yeah. Gave me everything. Didn't give me quite everything. If it's going to do that, I'm giving up. It won't give me that molecule. Forget it. It's not happening. You do this on a test too, it's fine. This goes here. I'm not even putting it there. This is B. This is B. Forget about C. We're going to do C somewhere else. This is C. Copying the front carbon. There wasn't 3 BRs, right? 1, 2, 3, 2 BRs. Get rid of that extra carbon. And there was a, what else on the front carbon? Sec. Okay, now I need them a 180 from each other, correct? How do I know I need them 180 from each other? Most stable Newman has the bulkiest groups on the front and carbon 180 from each other. The name for that is anti, right? So I need to rotate. If you go from B to make C, that's the best. Because you know it's a 180-degree rotation, end of story. Do it. The H is 180 degrees away from where it used to be. It's now straight up. The sec iso group is 180 from where it used to be. It's here now. It's not drawing. I don't know why. And the other group is 180 from where it used to be, and it used to be there. And 1, 2. That's it. And that is lovely because everything's staggered, right? Staggered, and the bulkiest groups are not on top of each other like they were here. They are 180 from each other here. What's DA stand for? You don't have to write DA on your test, but dihedral angle between the bulkiest groups. Dihedral, because the front carbon's a stereocenter. Hedron, tetrahedron. Okay, good stuff, huh? Yeah. Okay, now if I wanted the second most stable molecule, which I did not ask for, but is a very good test question, I would want the gauche. So I would have this molecule and I would rotate 60. That carbon 60 there. Okay, and then I have the bulkiest groups 60 from each other instead of 180. And we got that one done. And next.